Here we go. De Movi's theorem. Here we go. This is not bad. You just got to remember the formula. We talked about this on Friday, so this is a little review. I just want to make sure to go back over it because it's at the very end of class. So I'm going to teach you, kind of run through this a little quick, give you one to do on your own, and then we're going to go to the new stuff. So let's write the formula out. Here we go. Shh. Taylor. R to the nth power times cosine times n theta of n theta minus I sine n theta. So what would we do with this? Well, look at the example I have. Negative square root of 2 over 2 plus I square root of 2 over 2 raised to the 8th power. Now, if you didn't know this formula, then you're looking at creating a FOIL problem and doing it a very long period of time. Okay? 8th power means I'm going to FOIL that many times. Okay? Having to take care of square roots, having to take care of i's and I squareds. It's a very long process that doesn't need to be done because you have a quick shortcut to get there. And that's the formula you see over there. De Moivre's theorem says you can write, if you know the trig form of a complex number, then you can raise it to any power at all with almost no effort. The only thing you need is r and theta. If I know r and theta, then taking it to whatever power is very simple. But you're going to have to be able to get to that point, which we just did. We found r and theta in the examples on the board in the warm-up. And so if you can get to these points by doing like number 3 or number 4, then raising it to the 8th power is super easy. And so how do we know without any work at all that that's negative 135?
If x is negative and it's square root of 2 over 2. So you go that way. That's 45 degrees.
So here's a little trick. If your a and your b in the complex number are the same numbers, without concern for the signs. Here I got square root of 2 and square root of 2, right? Square root of 2 over 2 and square root of 2 over 2. If these two values are exactly the same, then you are going to have a version of 45 degrees. So if they're both positive, like square root of 2 over 2 plus square root of 2 over 2, that's going to be 45 degrees. In this case, if it's negative square root of 2 over 2 and square root of 2 over 2, that's an x negative and then positive in the y, so it puts you in the second quadrant. That's 135. What if they were both negative? It was minus square root of 2 minus I square root of 2. It'd be in the third quadrant, so 225. And then if it was square root of 2 over 2 minus I square root of 2, 315 because you're in the fourth quadrant. Little shortcuts, little things to note, save you a little bit of time and effort when it shows up. Okay? Sometimes you're going to have other problems where it's going to be all kind of crazy numbers, and you're just going to have to depend on your calculator, okay, to get it back to you. You may have, like an example on the board, we may have a decimal, and you'll round that to whatever we've talked about. So, anybody want to guess what R is?
R is going to be, I don't know.
So here's my work. I have negative square root of 2 over 2 squared plus square root of 2 over 2 squared. What's the square root of 2 over 2 squared? It would be 2 over 4, or 1/2. Good. So what's 1/2 plus 1/2? And the square root of 1 is 1. Okay? So what we know is we have theta to be 135. We have r to be 1. And we have 8, or my n is 8. Okay, now here's what they have to give you. They have to tell you n. If they don't tell you n, then there is no problem, because I have to raise it to a power. N is my power. Or in the next example, it could be a root, but n is that exponential you're going to be dealing with. So the only thing I have to do now is I have to take my values from over here, and I have to take them and I have to plug them into my formula up top, right here. Questions about what we're going to do? I want you to plug them in and see if you can come out with the power. Here we go. Check your work. There's two versions of the answer. So this is the actual process. Work those out. Z equals 1 times cosine of 1080 times sine of 180. Now, is the 1 necessary? No, but I just put it there for effect. if I had a value of 1, then you would need it there. And you would distribute, but you could also leave it just like this. Okay, I also asked you to write it out in its rectangular form, which means nothing more than go ahead and literally work it out. What is the cosine of 1080? What is the sine of 1080? Because in this problem, if you look at it, cosine, this is A plus BI. So if I find out what those values are, and of course if I had a number for B for my R, or my R to the power, then I would actually have to distribute the R into those values. But if I let that finish out, I could write it in the shorthand form, or we could write it in its other form, which would be what? It's going to be what? Cosine of 1080 is 1 plus 0i, or just 1. That's its rectangular form, a plus bi. We good? This is real simple. It's just, here's the formula. Can you find r? Can you find theta? And then do those, plug it into the formula and work it
I
out.
feel like this isn't hard.
No, not hard at all. This is old too. The next part, I don't think the next part's hard. It's just, it's a lot of work.
Jake's still my calculator.
Why? Okay, here we go. Shh. Finding the nth root. So let me put the formula up and let you write that down, and then we'll go through it.
Jake would sleep with
Is this brand new?
Yep.
What is this? What are you
Shh, brand new. Brand new. Shh. Do you remember how on Friday?
I quit.
Okay. No, don't quit.
You said okay.
Don't quit. Just kidding. Listen carefully. Remember last time on Friday, I told you if you wanted to raise it to a power, I gave you de Mauvaire's theorem. That's what we just got through looking at. Okay? Now we're going to turn around backwards, and what about taking the root? What about the square root, or the cube root, or the fourth root?
I don't care.
How would I do that using the same idea? It turns out that you do exactly the same thing. Okay? Okay, I'm going to get to it. Just chill out. Okay? We're getting there. Okay? Nth root, to find the nth root, I use this formula. You notice the variables are n, theta, and k. They will give you k and n. You may have to find r and theta, or they might give you those as well. The only thing you have to do is plug those in and work it out for each of the variables. Now, how many times do I have to do this? Well, if I'm looking for a cube root, that means there are 3 roots. I will do it 3 times. If I had a fourth root, I'll do it 4 times. Fifth root, 5 times. They're not hard. You're just changing one number each time. So here's how it works. We'll start off with a real simple example. Yeah, listen. Here we go. Let me write it out like that. If I give you the complex number -1. Remember what we did earlier. If I tell you that it's on, if it's just a real part, just imaginary part, that means the other part's at 0. So if I change that into its complex form, or write it with the I part, you're going to get -1 plus 0i right here. So if I have that, I know what A is, I know what B is. It helps me think about, well, what is my angle? What is the angle for this? What's the radius? Or what's the theta?
180.
It's 180, or pi, whichever way you want to think about it. Okay? What's my R? It is 1. Very good. So if we write these out, let's write it out in complex form, in the trig form. And so you have cosine pi plus I sine of pi. The radius was 1, so it didn't really have any effect, so I didn't write that in. And theta was pi. Or if you used 180, that's fine too. Okay? Now, let me talk about k for a minute. K depends on whatever your n is. In this case, we're looking to find the cube root, so n is 3. So k is every whole number less than 3 down to 0. So k would be 0, 1, and 2. Another example, if n were 5, we're trying to find the 5th root, then k would be 0, 1, 2, 3, 4. You have 3 k values because I'm finding the cube root. It starts at 0 and goes up by whole numbers. Okay? So if n were 2, you'd have 0 and 1. So k is really simple to find. They're not going to tell you k just verbatim, but they are going to tell you what n is. They can't leave that part out because that's the entire problem. Find the blank root. If you don't know what root to find, then you can't do the problem. So we go ahead. What we're going to do is we're going to start off with z. I'm going to label them z1, z2, and z3. I'm going to plug in. Go back to the top. Let me just kind of explain what we're going to do with this. Shh, listen. If you go back up here, look at the problems. Okay? You've got r. We know r. There's your n. We know what n is. That's 3. So this is going to be the cube root of 1, which is just going to be 1. The only part here, theta, I know what theta is. That's 180 or pi. K, well that's going to change. I'm going to start out using 0, then I'll do 1, then I'll do 2. And then the n on the bottom is also 3, and that same thing for over here. So it's really just a matter of me going through the process of plugging the different numbers for k in. Not hard, but a little tedious at times. I'm not really going to make you do anything more than a cube root. If you can do a cube root, you can do a 5th root. It's the same kind of thing, just more times. Okay? So here's the work for the first one. I'll plug in, actually that's a typo. I'll fix it in just a second. But, let me put it all the way out. There we go. Okay, so I want you to look at just this part. I went ahead, I took my formula from up top. I went down here, I plugged in every value. Notice the r to the nth root is gone. Why? It was 1, right? So if I take the 5th root of 1 to the 3rd root of 1, it's just 1. So that one I can leave out. So that's why you don't see an r there.
What does that say, pi?
It's 2 pi times 0 on both sides. This is the same thing for both. So
Pi plus 2 pi?
it's pi plus 2 pi times 0. And this side, it's easy to see where the sign is. Pi plus 2 pi times 0 over 3. Basically what I did was I plugged in my theta, I plugged in my k, I plugged in the n for the values up top. When I simplify that, well, the 2 pi times 0 just goes away, and you're left with just pi over 3. So I have to find what's cosine of pi over 3, what's sine of pi over 3. Well, pull out your left hand or your unit circle, bring that back up from memory. So tip to self, if you don't remember the unit circle, tonight is a very good night to begin to review that. Okay? If you forgot how to use your left hand, the video is still up. It's chapter 5. Scroll back down. There's a whole bunch of videos in that section. Okay? If you memorized it, you just straight up memorized it, you might need a little refresher. I think you'll just take a few seconds. Once you look at it, you've got a good deal going on. But what I don't want here is decimal values. If you put decimals in, okay, my instructions for this kind of problem is probably going to be exact. Well, you could use 180. You could use degrees, but you're going to have to remember the square roots and stuff.
So there's going to be 3 different equations that you're answering?
Mm-hmm. Oh, no, 3 different. Let me just keep going. What's the answer for Z1? It's just that last part. That's the answer for Z1. Just 1/2 plus the square root of 3i over 2i.
Oh, I guess it's not really an equation.
That's just the answer. Then I'll circle those when we get to the end. Let me put the rest of them up. I don't put that extra step in. I plug it in, and I work it out and simplify. And you get to the answers this way.
There's supposed to be 0 on the second one. 2 pi.
Will you have it again? 2 more times?
So you do it again, but just...
But with the second time, what I changed was I let k be 1. So you had 2 pi times 1, and I add that to pi, so I get basically 3 pi over 3, which is just pi. So what's the cosine of pi? -1. What's the sine of pi? 0. That's where you get your two values, -1 and 0 from. Right?
Yeah.
The next part, we say we let that, well, what's this cosine of 5 pi over 3 and the sine of 5 pi over 3? We let those work out, and you get 1/2 minus the square root of 3 over 2i. So those three circles, the blue circles, are the actual solutions to this problem.
So is it?
That's okay. Go ahead.
So is it always going to be like one of our unit circle things?
No. Okay? But these are the ones that are going to require you to do the most simplifying. That's why we did this one first. If it turns out that your angle that you're working with turns out to be something crazy like pi over 12. This is our next example. Pi over 12 is not on my unit circle. I can't do that by hand. If I say be exact, then chances are you'll leave your answer in its trig form and not reduce it. If I say reduce it and it's not, you'll pull your calculator out, you'll hit sine of 37 degrees.
Can we just do this in the calculator? Right?
Not really. Because it won't give you the trig form. You might be able to. I don't know. This is by hand anyway.
Wait, how do you use the 4 pi?
Okay, in the last part here, remember, go up to the top. I plugged in 2 for z. Or sorry, for k. So you get 2 times 2 pi. So if you really think about this, the first one I'm going to be adding 0 every time. The second one you're going to be adding 2 pi every time. The third one you're going to be adding 4 pi every time. Does that make sense? So every time that you do this, it's the same thing. Add 0, add 2 pi, add 4 pi. And give me the results to theta.
So that one's 5, it'll end up being 5 pi over 3?
Right. So that would give you this thing. So you know 1/2 positive and the square root of 3 over 2 is negative. Questions about this form? I'll give you one to do on your own to practice. You need to do it. Okay, let's try it.
Wait, go back.
That's why I said, are you do? Shh. Here we go. I want you to find the cube root of this equation. Start out with something fairly simple. Take this for a minute. I want you to work this out. I've given it to you already in its trig form, so you don't have to find it. Go ahead. I want you to find the cube root. So I want you to find z1, z2, z3. 3 solutions. So r is 2, theta is pi over 4, and n is 3. From this problem, I could just, from the way they gave it to me, because they already turned it into trig form, so I just had to look at the problem, go ahead and plug in to my nth root formula, and just work it out. Because n is 3, that means k is 0, 1, and 2. And to be honest with you, we're going to most likely do just cube roots for this. Yes, please leave it in trig form. Mm-hmm.
Oh, so we don't have to.
That's 0.
So that's
So it's
0, pi over 4 over 3.
Right. So do keep, change, flip.
So we don't have to get into complex.
Leave it in its trig form. You should get a theta of what? Pi over 12. Yep. And really, once you got that part down, it's not a really big deal. What's wrong?
That's what I did here.
No, you didn't flip it. It's 3 over 1. You just brought it up. You have to flip it. Be careful. When you have pi over 4 over 3, it's flip that so you get pi over 4 times 1/3. Then that's where you get your pi over 12 from. Yes, ma'am.
What are these blankets for?
Blankets. Those aren't blankets. Decoration for right now.
What?
So they're decoration for now.
What are they?
If you change your radians in this problem 2 degrees, that can be problematic. Because what's my formula got built into it? 2 pi. If I change the degrees, what do I need to make sure to change that 2 pi to? I need to make it 360. If I don't, I'd have 45 plus the 2 pi, and that's mixing your units, and that's going to be wrong no matter how you work it out. So if you work this out, this is what you get. Pi over 4 over 3 plus I sine of pi over 4 over 3. That's actually going to give me pi over 12 for both problems, right? And so the first solution would turn out to be this. I'm going to leave it like that.
Why is it so complicated when you're
That's what I'm like.
Well, that's not all of it. Who's got the second? Go to the board.
3 pi over 12, so you can reduce it to pi over. Three pi over 4 over 3.
Wouldn't it be 9 over 12?
Okay. Shh. Shh. We're going to write the other one. We're going to write the second solutions up. We may not have enough time for the third one. But the next one, the only thing that's going to change is what?
Okay.
Theta. K is going to change to change my theta. What do you get for theta for the second one? No, theta. You get 3 pi over 4. Has anybody got the third one done? We're almost out of time. What would I be adding? It's going to be pi over 4 plus 4 pi. So that's, what's 4 pi in terms of fourths? 17 over 4 over 3.
Is it for the second one?
So 17 over 12 pi. So 7.
Isn't it 3 pi over 4
Yes.
over 3?
No, that's after you. You had 9 pi over 12 over 3 or something like that.
No, look, here.
Or 9 pi over 4 over 3. I don't remember. It's 9 pi over 3.
So theta is pi over 4, right?
Shh. Hold on. Shh. Quiet, please. Your homework, now, real quick, you've got 31 to 43 odd. That's kind of what we did today. That's 2 things. De Moivre's theorem, raising things to powers, and the nth root formula, taking them down to the roots, just like we got through doing. Make sure 3 through 30 on from Friday. Okay, that's the other part where you grafted, you found it, you converted it into its trig form, things like that. Make sure that you know how to do that. You want to bring both of these homework sets tomorrow. It's a good idea, saying.
What?
Okay.
Gun.